Okay, so here I have a problem with a matrix times a variable matrix plus another matrix, and it is equal to a matrix that is times the same variable matrix. So, how do you solve for this variable matrix now? Because as the question input field is implying, this isn't a scalar. This is another matrix that is being multiplied by this matrix and this matrix here to give you, this equality. So let's go ahead and solve this. Let's go ahead and start and rewrite the problem. So that's what this line here is. And what we're going to do is we are going to rewrite this variable matrix as A, B, C, D, like it is done here. Now, you don't have to write A, B, C, D. I just find it's easier to do like that. I mean, you could write it X1, X2, X3, X4. But I personally find it easier if you go ahead and write, A, B, C, D. That's just me. So we're going to do matrix multiplication. So you might have noticed these orange rectangles are already here. That's because when you do matrix multiplication, quick little note, with matrices A and B, products of A on the left side times B on the right side is not equal to B on the left side times A on the right side. These are not equal matrices. I mean, sometimes they might be, but generally speaking, it is not okay to just simply say that those two are equal. Now, what I'm going to do is I'm going to take the top row of the matrix on the left, and I'm going to multiply it by this column here in the matrix on the right. And what it's going to give me is 4 times A, so negative 4 times A. So here I have negative 4 times A. And then I'm going to go ahead and do 1 times B. 1 times C. And that's going to give me this. And you're going to add them together. Matrix multiplication, that's how you do it. So I have, again, 4 times A, negative 4A. I'm going to add that with 1 times C. So I'm taking the elements of this row and multiplying them by the elements of this column and then adding. And then so once I have done that one, I will then go ahead and do for this column over here. And that gives me the results over here. So I have now negative 4 times B. So negative 4 times B here. And then I'm going to add that with, so here's that plus sign, plus 1 times D. So I have 1 times D here. And so I'm sure you get the point now. So then I would go ahead and repeat the same procedure for the next row in the matrix on the left. And then so I'll, multiply by this column, and that's going to give me this entry here. And then I'm going to multiply it by this column, and it's going to give me this entry over here. So once the matrix multiplication is finished, you should have your equation looking like this. This matrix here times this. This matrix here is still being added, and this matrix here is still being multiplied by the same variable matrix. Simplifying, we now have this, a lot easier to read. This is the matrix, and we have to add it with this matrix here. Well, matrix addition is very simple. Matrix addition is literally just taking this entry and adding it to this entry, and then making a new matrix. So when I go ahead and I add this entry with this entry, then I get this. Negative 4A plus C is this, and if I add it with 7 on this side, then I have plus 7. Similarly, if I have negative 4B plus D, and I'm adding it with this entry over here, then I have negative 4B plus D plus 1. So you add the matrices, and now you just have a much simpler looking left-hand side and the exact same right-hand side. Now, matrix X here is the same on the left side and on the right side. So on the left side earlier, we had rewritten it as A, B, C, D. Well, then we can do the same thing on the right side because, again, matrix X equals matrix X. So now we have a similar thing where we have this matrix here times the matrix A, B, C, D, which again could be X1, X2, X3, X4. So following the same procedure that we had followed when we multiplied it, over here, we then have the following matrix here. So this is the product of this 2 by 2 matrix X and this matrix we had been given. And they are equal to each other, which means that this entry here is equal to this entry. Likewise, this entry here is equal to this entry, and so on until we've covered all the entries. So then it follows that we now have a system of equations. So again, like I said, this one is equal to this one, then that's reflected here in this system here. So there's 4 entries, so there's 4 equations in this system here. Now, over here I had simplified them so that, the variables were isolated to one side. So for this one here with the 4a plus c plus 7, I had simplified that, and I had found out that a plus c equals negative 7 plus 4. I had then done that for each subsequent equation, until I reached the bottom. So that gave me then b plus d equals negative 1/4, negative 9a plus 17c gives me negative 6, and negative 9b plus 17d gives me 4. And so that is reflected in this matrix here. This matrix here is just showing the coefficients of the variables and what they are equal to. So here I had showed you that a plus c equals negative 7 divided by 4. This is the same thing as 1a plus 1c. So likewise, if you think about it as a, b, c, d, well, there's no b, so we can say that the absence of b is equal to 0 times b equals 0 because there's no such thing. Likewise, in the b column here, it's 0. But again, a on its own is equal to 1a, and we have 1a plus 1c equals negative 7 over 4, so we have a 1 in the a column and a 1 in the c column. But again, b and d aren't there, so they just do not show up. They're 0 for this entry. And again, this equation yielded negative 7 over 4, so that's on this side over here on the augment. So I had plugged all these in, I had simplified, and it gave me this matrix. Then what we did is Gauss-Jordan elimination. So Gauss-Jordan elimination is, it's the elimination in matrices so that you get reduced row echelon form. And reduced row echelon form looks like this over here, the solution, where it's like a diagonal. It's a staircase of 1s, and all numbers around the diagonal are 0. So for a 2 by 2 matrix, it would look like this. For a 3 by 3 matrix, you would have this. And I'm sure you can see how it's 1 in the diagonal, but then all the other numbers around it are 0. This is called reduced row echelon form, and the point of Gauss-Jordan elimination is to manipulate the matrices so that you get that form of the matrix. Notice how the augment, however, doesn't have to follow this. The augment is, again, just a solution to the system. So, running through this elimination, now it doesn't make sense to show it to you for this particular problem because each one is going to have a different set of procedures to get in this form. In fact, these procedures you would follow aren't even unique, so it doesn't even matter. So then you would do Gauss-Jordan elimination on this matrix to figure out the values of the variable. So again, here we have a coefficient of 1 for the variable d, because again, a, b, c, d. Therefore, if 1d equals this number over here, then d itself just equals 7 over 104. And so similarly, I had written this here, that x4 equals negative 7 equals 7 over 4 equals d. And like I said earlier, a is the same thing as writing x1, b is the same thing as writing x2, blah, 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 until you get to d equals x4, which is why I wrote x4 equals 7 over 4 equals d over here. And again, so if you now have these isolated variable values, and I told you that the matrix X equals something like this, then it follows that matrix X equals, whatever these values are over here, plugged into the matrix. So this is how you would solve this problem. The inputs I gave were correct, and you get it wrong. This methodology is correct, but since there's a lot of steps in this row reduction stuff, it might have been in your row elimination where you made a mistake. I would recommend trying to plug in your matrix into a matrix calculator online. The one that I really like to use is, let me find it, called Matrix Reshish. So matrix.resish.com is a good matrix calculator to use for this, and it will give you the answer once you set up your matrix. And that's all you do. But again, so let me show you a different problem where I had actually messed up. It's similar, it's not exactly the same. There's only one X matrix on any of the given sides. But again, it's a lot of steps. I mean, look how much space I have to scroll through before I get the solution. So if you get it wrong, go ahead and look at your matrix calculations again. And if not, if you don't want to go ahead and do it again, go ahead and look up one of the calculators and see what it gives you for your solution, and then it should tell you the variable values. But this is the methodology for matrix algebra like this.